Good morning guys and welcome to today's video on GCSE Maths Revision for Exams Part 3 series. Right guys, this video was filmed on Tuesday the 21st of July 2020. Right guys, if you're new, welcome. My name is Abdallah W and I'm a private maths tutor. I make maths videos on Key Stage 1, Key Stage 2, Key Stage 3, GCSE and A-level maths, as well as further maths, as well as undergraduate degree. Okay, please do subscribe to my channel if you're new. Drop it a like, enable notifications by pressing the bell icon, because it would really help me out, guys. But let's get on with today's video. Right, guys, so in today's video, it's a part 3 series of the revision, actually. So I've made this video, guys, okay, obviously for like two reasons. One reason is because I've started to obviously increase the number of subscribers actually to my channel recently. So I started my channel, I believe, back in October this year. So I want to recover topics that I've not actually had chance yet, obviously, to cover, like obviously in my previous videos this year. So it's to save you time of like traipsing through all my older videos, okay, because I've made quite a lot of videos this year, especially in this whole quarantine period this year during 2020. Okay, so it's just obviously like a nice easy way of like revising your topics and keeping on top of actually your topics. I've not covered every single topic actually, because some of them are a bit trickier than others to like recover. Okay, but you're welcome to take a look at like any other topics here that I've not covered yet from this 3-part series. Okay, so our plan today, guys, is to cover these topics for our revision actually, and then I've put the grades here as well for you guys to refer to actually, for the GCSE curriculum 9 to 1 for Edexcel, AQA, OCR, and WJEC specifications. Okay, right guys, let's get into today's video. Okay, so today's lesson actually, so first topic, okay, so arithmetic sequences, so it's going to be grade 4. Okay, right guys, so a sequence here is a list of numbers that follow a pattern. Okay, so what I'm saying here is that a arithmetic sequence, guys, is that I'm adding or subtracting the same amount every time. So for example, I could be adding 4 each time, I could be subtracting 6 each time, I could be adding 100 each time actually. Okay, these are what I call arithmetic sequences, that they have like a fixed pattern. So it's the fixed amount, okay, each time actually. So it's a fixed same amount that I'm adding each time. Okay, so I've got an example here actually. So 4, 6, 8, 10. So we can see here, guys, is that we are adding 2 each time. Okay, so add 2, and add 2. Okay, so the next term, if you're interested, it will be 12, because 10 and 2 is 12. Then the term after that will be 14. Okay, and so on and so forth. Okay, for this. Okay, I can work out, okay, what I call like a term-to-term rule, a general rule, to actually summarize this. Okay, so I'm going up each time actually in 2, so it's going to be 2n, okay, because 2n follows the 2 times table, okay, if that makes sense. So 2n follows the 2 times table actually. So it's 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, and so on and so forth. Okay, but the 2n, okay, has the rule 2, 4, 6, and 8. But we've got the pattern 4, 6, 8, and 10. So to get from here to here, I've essentially added 2, okay, to 2n. Because 2n gives me this sequence here, and then adding 2, so 2 plus 2 is 4, 4 plus 2 is 6, 6 plus 2 is 8, 8 plus 10 is, should be a 10 there, sorry, 8 plus 10 is, 8 plus 2 is 10, sorry, and so on and so forth. So 2n plus 2 is my general rule for nth term for an arithmetic sequence, guys. Okay, so I hope that actually makes sense, guys. Obviously comment below if you've got any questions or queries about any parts of this video actually, or any slides. Okay? Right, guys, next one. Okay, so here is another example, actually. Okay, so arithmetic sequences. So 10, 7, 4, and 1. Okay, so each time we are subtracting by 3. Okay, so the next term, it would be 1 minus 3, which is minus 2. Okay, and then the term after that, actually, it would be minus 2 minus 4 minus 3, which gives me minus 5 as my answer. Okay, so that is that. Okay, right, the next part says find the nth term of this sequence. Okay, so we know that we are going down each time by 3. Okay, so again, it will follow the pattern minus 3n. Okay, for that. Okay, right, guys, so obviously when n equals 1, I get minus 3. Okay, when n is minus 2, I get minus 6, minus 9, and then minus 12. Okay, sorry, put it up here, minus 12. Okay, for the next one. Okay, we've got the sequence 10, 7, 4, and 1. So, to get from minus 3 to 10, I've got to add 13. Okay? So, to go from here to here, I've added 13. Minus 6 add 13 gives me 7. Sorry, 7, not minus 7. Again, minus 9 add 13 is 4. Minus 12 add 13 is 1. So my nth term is minus 13, 3n plus 13. Or I can write it as 13 minus 3n. Either way is correct. Okay? Obviously, making sure, that you're consistent with your signs. Okay, so either answer is correct. So it's this or this. Okay, and then that is my nth term, guys. Right, guys, next question. Here is an nth term of a sequence, actually. Okay, so this time we're given an nth term. We are asked to work out the first 3 terms. Okay. Right, guys, a little note, actually, yeah. So when I'm looking at sequences, actually, we are always looking at the first term, actually. So first term when n equals 1. So n can never be equal to 0, actually. So the first term is always when n equals 1. So n cannot ever equal 0. Okay, yeah. For your nth term. However, you can have a 0 term as part of your sequence, but the actual term cannot be n equals 0, if that makes sense. Okay? Yeah, so 4n minus 1. Right, first 3 terms, n is 1, 4 times 1 is 4, minus 1 is 3. Okay, so the first term is going to be 3. Next term is 4 times 2, which is 8, minus 1 is 7. And then when n is 3, 4 times 3 is 12, minus 1 is 11, okay? And then, and then number 4 would be, 15, okay? So, I'm adding on 4 each time, okay? Right, next one says, work out the 800th term. Okay, so 4 times 800 is 3,200, minus 1 is 3,199, guys, okay? So that is how I do that, okay? And the nth term, actually, so it's used here because you can work out any value in your sequence, okay? So if you wanted to work out, I don't know, obviously the 1000th term, you can by subbing it into there. You can work out the 100 millionth term, okay, or the billionth term, actually, if you want, by just subbing in the value for n into here to work out what that value would be, for the 100th million term, actually, or the 1000th term, or the 100,000th term, and so on and so forth. Okay, so that is the purpose for that, guys. Okay. Right, guys, okay, so quadratic sequence, guys. Okay, so this time, okay, so next part, actually, so it follows the rule an squared plus bn plus c. Okay, so we have like an example here, so 3, 8, 15, and 4, 24. Work out the nth term. Okay, so the rule here, guys, is, so we're going to work out what we call our first difference. Okay, so so 3, that's going to be a 5. Okay, 7, 9. Okay. So we know straight away, yeah, that this cannot be a arithmetic sequence actually, because I am adding on different amounts each time. So that's the rule actually for that actually. Okay, but then what I'm gonna do is I'm gonna work out a second difference, plus 2 and plus 2. Okay, and you will see why I'll be doing this in a minute, guys. Okay, right, guys, I've got the term actually a squared actually plus bn plus c. Okay, when I sub in n equals 1 into here, it will give me a plus b plus c for my first term. Okay, so subbing n in there, 1 squared is 1 times a is going to be a, b times 1 is going to just be b, and then I've got plus c. Okay, right, n equals 2, guys. I'm going to get 2 squared, which is 4, so I'm going to get 4a, okay, plus 2b plus c. Okay, and then n equals 3. I'm going to put that into the quadratic here. Okay, expression. Okay, 3 squared is 9, so it's going to be 9a plus 3b plus c. Okay, sorry about my handwriting there. So 9a, let's just do that again actually. So it's 9a plus 3b plus c, guys. Okay, and you will see this will become apparent in a second why I've actually done this. Okay, right, I'm now going to find the common difference. Right, a to 4a, I've added 3a, and then b to 2b, I've added b, and then c to c, I've just added 0 actually here, so I've just added 0. Okay, from here to here. Okay, and then from here to here, I'm going to have 5a plus b, because 4a plus 5a is 9a, 2b plus 1b is 3b, and then c plus nothing is going to give me c, okay? So that is my first difference. Right, my second difference, guys, 5a minus 3a is going to be 2a, b minus b is 0. Okay, and what I can now do, guys, is I can say to you that these three numbers, okay, 3, 5, and 2, follows this pattern here. So I can say that 2a is equal to 2, okay? So it's come from this number here and then this number here, okay? Because they are the same numbers at that point. And then I can also say to you that 3a plus b is equal to 5. Okay? And then I can say to you that a plus b plus c has to equal 3. Okay? So that is the rule there. Okay? Right, guys. I've now got an equation here. 2a equals 2, so therefore a must equal 1. Okay, so straight away we know what a is. Okay? We can then sub in a equals 1 into here to work out what b is. 3 times 1 is 3. 3 add 2 is 5. So b is equal to 2. And then finally, now that we know what a and b are, I can sub these two into here to work out what c is. 1 plus 2 plus c is 3. Well, 1 plus 2 is 3, plus c has to be 3, so c has to equal 0. So my answer would be n squared plus 2n. Okay, or yeah, or 1n squared, yeah, plus 2n. Either way is fine. Yeah, so a is 1, so it's 1n squared, yeah, plus n, or yeah, or just write, yeah, n squared, and then plus 2n. Okay, so that is a summary of quadratic sequences, guys. Okay, so I hope that actually made sense, guys. Guys, next slide actually. Right, so solving inequalities. Right, so solving inequality, x plus 3 is bigger than or equal to 7. Okay, so this is like solving an equation, so we're going to work backwards. So I'm going to have to minus 3 on both sides. Okay, so x is bigger than or equal to 4. Okay, so inequalities just means that I have these signs to be, yeah, so I've got what we call these signs. Okay, yeah, and they can be expressed on a inequalities line. Okay, because what this is saying here is x is bigger than or equal to 4 actually. So it's saying 4 or more, okay, would satisfy this inequality here, okay? So on your number line, if it's 4 or more, okay, yeah, it will look like that, and I've shaded it because I've got that equal sign there. So it's a hollow circle if it's not got the equal sign, and then it's a shaded circle if it's got the equal line below. Okay, so this is the inequality, yeah, obviously drawn on here for this sketch of x is bigger than or equal to 4. Okay. Yeah, so that's there. Okay, yeah, but we'll just stick to obviously, yeah, the purpose here of actually solving these, yeah, as part of today's lesson. Right, next one, solve 2x plus 7 is less than 10. Right, minus 7 minus 7. Okay, on both sides. Okay, because I'm trying to get x on its own. 2x is less than 3. And then finally, 2x means 2 times x. So the opposite of times by 2 is to divide by 2. So x is less than 3 over 2 or 1.5 or 1.5. Okay? So that's our answer. Right, next one. X over 3 minus 6 plus 9. Okay, so what I'm going to do is I'm going to add 6 to both sides. X divided by 3 is bigger than 15. And then the opposite of dividing by 3 is to times by 3. So x is bigger than 15 times 3, which is 45. Okay, so that is my solution there, guys. Okay, so x is bigger than that. Okay? Okay, and then the last one, yeah, try this question, guys. Okay, yeah, and then I will put the answers to that one, yeah, in the comment section tomorrow. Okay. Right, guys, next part. Okay, so we're nearly there, actually. Okay, so let's solve. Okay, so quadratic equation. Okay, so grade 6 7 actually. So quadratic equation is in the form of ax squared plus bx plus 0, and it has two solutions. Okay, so a key note, guys. Yeah. So if it has an x squared actually, an x squared term, then it always must have two solutions. Okay. And it has solutions of the form x is equal to minus b plus or minus the square root of b squared minus 4ac all over 2a. And then this is known as the quadratic formula. Okay, sorry about my handwriting today, guys. I apologize. Okay, I will try and yeah, I will try and get like a mouse next time, so it makes it a bit easier. Okay. Right, so some some quadratics can be factorized, and you can also use completing the square method sheet. So there are multiple ways here to solve a quadratic. Okay, but if you're ever stuck, actually, guys, if you're ever stuck or unsure, a quadratic formula here will always give you the solutions to the equations. So yeah, so if you have an exam and you're thinking, oh, I'm not sure how to factorize or complete the square, actually, just use the formula here, and it will tell you obviously how to actually work it out. Okay. Right, guys, okay, so we've got two examples here actually, yeah, so factorizing quadratics. So we've got example 1 actually, so solve x squared minus 3x minus 10 is 0. Okay, so x minus 5, okay, and x plus 2 is 0. So it's two numbers that add to make minus 3, and then multiply to make minus 10. Okay, so add to make minus 3, and then times 11. So you've got factors of 10 are 1 and 10, and then 2 and 5. Okay, well, 2 and 5 does make 3, but to make minus 3, it has to be minus 5 plus 2, okay, or plus 2 minus 5, okay? So plus 2 minus 5, okay? So that is that one there, okay? And then we say either x plus x minus 5 is equal to 0 or x plus 2 is equal to 0, okay? So our solutions are x equals 5, okay, so adding 5 to both sides, or x equals minus 2. So they are my solutions to the quadratic. Right, example 2, guys. Okay, so, so solve x squared plus 2x minus 15 actually equals 0. Okay, again, two numbers that add to make plus 2 and times to make minus 15. Okay, so factors of 15 are 15 and so 1 and 15 and 3 and 5. Okay, so to make positive 2, okay, it will be plus 5 minus 3. Minus 3 times plus 5 is minus 15, so that's correct. And then plus 5 minus 3, it gives me plus 2, okay? Yeah, okay, so x plus 5, x minus 3, okay? Okay, so then solving this, I get x is equal to minus 5, x equals 3. So they are my two solutions to the equation, guys, okay? So yeah, so it's always, yes, so if you're factorizing, it's always two numbers that multiply to make the n number and add, okay, sorry. Right, guys, okay, quadratic formula actually. Okay, so this is the second to last topic, guys, okay, for today's lesson. Okay, so sorry that I've gone on for a while, actually, yeah, but it's just, again, this is for like, revision purposes, guys, okay, so, it is for GCSE, revision, actually, yeah. For that. Okay, so solve the equation x squared minus 3x plus 5 is 0. Okay, so this cannot be factorized, so we're going to use a formula. Okay, so x, okay, so we know what a, b, and c are. So a is equal to 1, b is minus 5, and c is 3. So it's ax squared plus bx plus c. Right, so it's x is equal to minus b, which is going to be 5 plus or minus the square root of minus 5 squared. Oops. Okay, minus 4 times a, 4 times 1 times 3. Okay? And then all divided by 2a. Okay? So that will be that one there. Okay? Oops, sorry. Right, so 5 squared is 25. So I'm going to get x is equal to 5 plus or minus, okay, 20, so 25, and then I'm going to have minus 12, okay, because minus 4 times 1 times 3 gives me minus 12, and then divided by 2, okay, so my solutions are x is equal to 5 plus or minus the square root of 13 divided by 2, okay, so my two solutions are 5 plus root 13, oops, should be 13 there, okay, over 2, and x is equal to 5 minus root 13 over 2. So they are my two solutions to the equation, guys. Okay, and then I would put them into my calculator, yeah, obviously to get a numerical answer, okay, but they're my two solutions, yeah, to the equation, guys. Right, guys, last part of the lesson today, yeah, okay, so sharing in a given ratio, so it's grade 3, 4, okay. Let's say I want to share £20 in the ratio 2 to 3, okay, so step 1, so you add the ratio pots together, so 2 plus 3, so we got 5 pots in total, okay. So here I've got 2 pots, and then it's the 3 pots, 2 parts to 3 parts. Okay, and then I divide the number by the total number of parts. So £20 divided by 5 gives me £4, which is equal to 1 part. Okay, so £4 is 1 part. So therefore, 2 parts will be 4 times 2, which is 8, and then 3 parts is 3 times 4, which is 12. Okay, so my answer here would be £8 to £12. Okay, so that is my ratio. And then I can check my answer by adding these two numbers. 8 plus 12 is 20, which is the actual value of the of the large number at the beginning. So you can check your answer by adding your like final answer together to show that you get the actual correct number at the end. Okay, so 8 parts of 12, 8 plus 12 is 20, so therefore that is correct. Okay. Yeah. Okay, so I hope that makes sense, guys. Right, guys. Next, let's do the lesson actually. Okay, so the plan is we're gonna look at Fibonacci's sequence in the next lesson. Okay, and then we're gonna start looking at Venn diagrams. Okay, yeah. So that is the plan actually. Okay, yeah. Friday's lesson. Okay, so I hope that was actually okay, guys. Yeah. I hope it made sense today. Yeah. Thank you so much for like watching. Yeah. Stay safe actually, and I hope everyone's doing well actually. Okay. Yeah, and then lastly, so thank you so much for watching, guys. Please do subscribe to my channel, drop it a like, turn on post notifications, and then share my videos around, and comment below any questions or queries that you might have actually. Okay, so yeah, so I really want to try and get to 500k by November this year, and then I want to try and get to 1,000 by end of December. Okay. And then also, guys, yeah, check out these links. So corbinmaths.com and then Maths Watch for like extra practice, for exam style questions. Yeah, and I hope that is okay, guys. Okay, so again, yeah, so thank you so much for watching, guys. Stay safe, and I hope you're all well. Okay, happy Tuesday. Okay, I will see you soon. Bye now.